Hello, welcome back to this video. This is 7-4, and we are going to be talking about logarithmic equations, solving some equations dealing with logarithms. All right, so let's go ahead and look at a couple of examples. All right, so here for example 8, it says solve for x. So what we're going to do, I want to go ahead and isolate x. So the first thing, we'll go ahead and subtract 6 on both sides. So y minus 6 is equal to e to the power of 2x minus 5. And here you're like, how do I get the x down from the exponent? Well, we're going to go ahead and utilize logarithms. So I'm going to take the natural log of each side. And maybe you're asking yourself, why is he taking the natural log? Well, look at the base of the exponential expression on the right-hand side. It's base e. So when I take the natural log, what ends up happening is that the base cancels, right? These two are inverses. So I have the natural log of y minus 6 is equal to 2x minus 5. And I'm going to go ahead. I will add 5 on both sides. And then I will divide by 2. And I get x. All right, so there is our answer for 8a. All right, 8b. What we're going to go ahead and do here is kind of solve this in a different type of manner. I'm going to first simplify this. Notice that these are both log base 2, and I'll combine these. So log base 2 of x over x minus 8 is equal to 3. So notice this is a logarithm. You can do a couple of things. You can raise each side to the power of 2 to cancel out that log base 2. But I want to show you another way. Notice that I can rewrite logarithms as an exponential. So I want to change the base, or keep the base the same. So base 2. Inputs and outputs switch. So 2 cubed is equal to our input over here, which is x over x minus 8. Okay, and after I go ahead and multiply both sides by x minus 8, we end up with 8x minus 64, right? This is 8 here, okay, and we'll distribute, and this is equal over here to x. So we'll go ahead, subtract x on both sides, giving us 7x. Add 64 gives us 7x is equal to 64, and x is thus equal to 64 over 7. All right, so there you go. All right, the next thing that I want to talk about is the change of base formula. This is an important property that you can utilize with logarithms to change your base, and it just says log base a of x is equal to log base b of x over log base b of a. So notice that the base changes. Okay, I have the same base, top and bottom, and then our argument goes in the numerator, and the current base is the argument of the denominator. Now, this is useful for calculators that don't have the ability to input a different base. Well, our calculators do. So we're lucky there, but just note that this is a property that you might see pop up, okay? And the common ways to rewrite this are with log base 10, okay? So log, again, base 10 here, and then log base e. So you may see these rewritten this way. So here it says, use a calculator to find what is log base 7 of 112 to 3 decimal places or more. So I'm just going to go ahead and rewrite it, kind of what they're talking about here. So log base 7 of 112 could be log base 10 of 112 over log base 10 of 7. Or you could go ahead and rewrite it as the natural log of 112 over the natural log of 7. Okay, so those are the ways. But again, our calculators, the TIs, we can go ahead and in our calculator mode, I can actually calculate this. So log base 7 of 112, that is 2.425. So this is approximately 2.425. All right. Okay. Example 10. Here it says, find the exact value of x for 3 to the power of x plus 2 is equal to 6. So what we're going to do here, I'm going to show you the long way first, and then I'll show you the shortcut. Okay, so just bear with me for the long way. And this is what we did in Accelerated Math 3. If I want to bring down a power, I have to use a logarithm. So I'll take the logarithm of 3 to the power of x plus 2, and this is equal to the natural log of 6. Now that I have a log, I can bring down that power out front, okay? And anytime you see a binomial, make sure you put parentheses around it, and I'll tell you why I'm doing this in a second. So I have x plus 2 times the natural log of 3 is equal to natural log of 6. Okay, so the reason I tell you to put parentheses is because you have to distribute this. Expand it out, this is x times the natural log of 3 plus 2 times the natural log of 3 is equal to the natural log of 6. Now I want to go ahead and I want to solve for x, so I'm going to shuffle everything that doesn't have an x in it over to the other side. So x natural log of 3 is equal to the natural log of 6 minus 2 natural log of 3, and now I'm going to go ahead and just divide by the natural log of 3. So x is equal to natural log of 6 minus 2 natural log of 3 all over ln of 3. And ta-da, there is the exact value. So I told you there's a shortcut. Another quick way that you might do this, notice, another way we can solve these is switch from exponential to logarithm or vice versa. So here, this is an exponential equation. So I'm going to switch from an exponential to a logarithm. Okay, so bases stay the same. Log base 3 of, okay, the output becomes the input, 6, and the input becomes the output, so x plus 2. Well, after solving, we get x is equal to log base 3 of 6 minus 2. Hey, and that's much shorter. And I know you're saying, hey, these are different. These are different, but they're the same. Okay, so and that's much faster. We can go ahead and input that in our calculator. So log base 3 of 6 minus 2. I believe that's our equation. Yep. Okay, and I'll go ahead and hit enter. And that is negative 0.369. Negative 0.369. X is approximately that. Okay, that's it. All right. Hey, that is solving logarithmic equations. Again, this is just a brief overview or a recap of what we did in Accelerated Math 3. Check out other videos on solving logarithmic equations if you're struggling or need some more practice, okay? And what I recommend trying right now, go to your problem set, try one of the logarithmic equations in your problem set. Try to solve that. Catch you next time. Peace.